Right now I'm going to be showing how to use the second derivative test. So like the first derivative test, this is used to find relative maxes and mins within a function. So the first step is actually to take the first derivative of your function that you're given. So right now I'm going to take the derivative of this function f of x is equal to x cubed minus 3x plus 4. So f prime of x is equal to 3x squared minus 3. Now to find the critical points, I'm going to be setting the first derivative equal to 0 and solving for x. So that's 3x cubed minus 3 is equal to 0. And now I could factor out a 3. So it would be 3 times x cubed minus 1 is equal to 0. And you could factor it out even further, which is 3 times x plus 1 times x minus 1 is equal to 0. So you learn that the critical points are plus 1 and minus 1. So after we found the critical points, next I'm going to be taking the second derivative of the function, because this is called the second derivative test. So of course we're going to be needing it. So to do that, I'm taking the derivative of the first derivative. So f double prime of x would equal just 6x. Now that we have the second derivative, I'm going to be using a number line as it's the easiest method. So I'm going to be drawing a number line here, with arrows and everything. And I'm going to be using those critical points as the points on the number line. So right here, I'm gonna have -1, and right here I'm gonna have 1. Now, what I'm gonna do is I'm gonna plug in these critical points into the second derivative to find its sign, whether it's positive or negative. And to do that, we could figure out if it's a relative max or a relative min. So if I plug in -1 to 6x, 6 times -1 would be negative. So it would be -6. So that point would be negative. While if you plug in 1 to the second derivative, you'll get just 6, which is positive. So in the second derivative, if it's negative, that means the function is going to be concave down, which is going to be shaped kind of like a hill, which means that this would be a maximum. -1 would be a maximum. Now to find the point, since we're going to be plugging -1 into the original equation, so I'm going to be doing that right now. So x, replace that with -1. So -1 cubed minus 3 times -1 plus 4 would equal, 6. Okay. And we could also do that for the other one, since we know that this is going to be concave down, kind of like a valley, so it's going to be a minimum. So we're going to find the point there. That's going to plug it into the original equation again. That would be 1 to the 3rd power minus 3 times 1 plus 4. Which equals out to be 2. So with these, we found the points -1, 6, and 1, And finally, to finish off, we're going to be writing these statements as it's required in the second derivative test if you want to get full credit. So, by the second derivative test, since f double prime of -1 is less than 0, so it's negative, we can say that the point -1, 6 is a max. And you could pretty much do the same thing for the other point, except you're going to be saying it's a minimum. So by the second derivative test, since f prime of 1 is greater than 0, the point 1, 2 is a minimum. And that's it.